Okay, so we have a question, which is how to find limiting reactant.
Yes, I don't clearly understand it that much.
Okay,
That's the one I had got stuck on quizzes,
yep,
and
yep,
that's the problem.
no worries. Will our labs from term 1 and the start of term 2 be included in our term 3 grade or our final grade? Everything from term 1 and term 2 will be included in the term 3 and final grade. Okay, so everything that we did. Are both quizzes due on the 18th? You know what? As long as you have them done by the end of the week, I will be happy. Okay, so make sure you've got those quizzes done. Otherwise, I'm going to have to be like, okay, you're not participating. Although, if you made it to this meeting, you probably are already participating, and probably the people. What about our textbooks? Yes, so your textbooks, I don't know what we're going to do about returning them at the end of the year, but if there is anyone who does not have a Hebden, because I will be, assigning some reading out of Hebden, what you're going to do is, if you don't have it at home, you don't have it at home, you are going to message me and I can send you an access code that will give you a PDF of Hebden. So if you have your Hebden at home, you're fine. But if you are missing a Hebden, message me for an access code. Okie dokie. Yeah, so any other sort of practical questions, or shall we just get to how to find a limiting reactant? All right, finding limiting reactant. So what you're going to do for any limiting 1 more mole ratio and limiting reactant, yeah, it's all the same stuff. So we'll get into that. Okay, so let me just find the correct page here. There we go. All right. So what we always do is, number 1, we find the moles of product. And if there's more than one product, you just choose one. Okay, it doesn't matter which one, just choose one that could be formed from each reactant. So that's going to be 2 calculations, okay? And we'll do an example where we see those 2 calculations, okay? Number 2, after you have found the moles of product, whichever reactant produced the least amount of product hang on 1 second. Okay, we're good. Okay, whichever one produced the least amount of product is the limiting reactant. Okay, because whichever one produces the least, that's the one that is limiting the amount of product that is formed. Okay, so let us try a question. Okay, so for example, if 20 grams, move this out of the way, got keyboards everywhere here. If 20 grams of H2 gas react with 100 grams 100.0 grams of O2. Which reactant is present in excess and by how many grams? And if you're wondering, will this be recorded? Yes, it will. I can also post a PDF of this um, question and work through, okay? So we need a balanced reaction because anytime you're doing any stoichiometry or anything like that, you need to have a balanced reaction. Okay, and our balanced reaction, we have hydrogen reacting with oxygen to give H2O. If I was to use my reaction just like that, I would get the answer incorrect. It would be wrong. So we need some coefficients. Let's put a 2 in front of our H2O. That gives us 2 oxygen because there's 2 oxygen on the left. And that means we'll also need a 2 there. Okay. Now, remember, step number 1, find the moles of product that could be formed from each reactant. So this is going to be 2 calculations. Okay. So our product, in this case, there's only one, H2O. We're going to figure out how much H2O can be made from reactant A, let's call it, which is the H2, and reactant B, which is the O2. Okay. So we want to calculate the moles of product from reactant number 1, reactant A. So that's going to be the moles of product H2O that can be made from reactant A, which is H2. So we are starting with H2, and we want to finish with moles of H2O. So how much H2 are we starting with? We are starting with 20 grams of H2. So we have 20 grams of H2 times, now if we want to go from H2 to H2O, we must be in moles first. So anytime you're doing something, if you start with grams, if you start with liters, if you start with molecules, always convert it into moles first. So we're going to cancel the grams of H2, and we're going to find the moles of H2. And the molar mass of H2 is 2.0. Okay, so that's for every 1 mole of H2. Okay, next we have to convert moles of H2. Where's my favorite highlighter? There we go. Moles of H2 into moles of H2O. So we want to cancel the moles of H2 and we want to find the moles of H2O. Where do we get the numbers for that conversion factor? You can just type it into the comments section. Where do we get the numbers to convert from moles of one substance to moles of a different substance? Don't be shy. Type it in. I got 2 people. That's pretty good. That's a start. Okay, yeah, it is from the balanced equation. It is the mole ratio. And so we're going to look at our numbers here and we're going to say, okay, what's in front of the H2? We have a 2. What's in front of the H2O? Oh, it's another 2. That makes my math super easy. There are 2 moles of H2O for every 2 moles of H2. And so we end up with here 20 divided by 2 is 10 moles of H2O. And you'll notice I went down to 2 significant figures because there are 2 sig figs here. Okay, so our answer here is going to have 2 sig figs. So if that turns out to be our limiting reactant, and we're asked how much product we get, our answer would only have 2 sig figs. Okay. Now we need our moles of product, because remember I said for step 1, this is step 1, you're going to do 2 calculations. You find the moles of product from reactant B. Okay, so we are starting with O2. How many moles of product, H2O, can we make from our O2? Well, how much O2 do we have? Let's go look in the question. We have 100 grams of O2. Okay, so that is 100.0 grams of O2 times 1 mole of O2, because we need to convert. First thing you do in any stoichiometry problem is convert to moles. Okay, always convert to what? What should I always convert to first? Everyone? Yes. Yes, yes, yes. We're going to convert to moles. Okay, so grams of O2 we want to cancel. Mass of O2 is 32.0. And I cannot do that kind of math in my head, but let's see what else we have here. We also need to go from moles of O2. Now we need to go to moles of our product. So we want to cancel moles of O2 and find moles of the product, H2O. And that's a mole to mole conversion. So again, that is from our balanced equation. We have a 1 here that doesn't show up. Okay, so there is 1 mole of O2 for every 2 moles of H2O. Okay, so 200 divided by 32. And that gives us 6.25. Okay. So now what we're going to look at is sig figs. We have 3 sig figs here and 4 sig figs here. So in our answer, because we are multiplying, we have a maximum of 3 sig figs, so it's going to be 3 sig figs. All right. So step number 1 is done. We have found the moles of product from reactant A. We have found the moles of product from reactant B. What is step 2? What do we do in step 2? Type it on in. Mm-hmm. Yep. all those things. We're going to compare the two. We're going to say which one produces less H2O. And by doing that, we are going to find our limiting reactant. So step 2. Find the least amount of product out of those two. And in this case, that is going to be our 6.25, because 6.25 is less than 10.0. Okay, 6.25 is smaller than 10. So this one is how much we are limited to. If all of our oxygen reacts, we can make 6.25 moles of water. Once we've made 6.25 moles of water, we have run out of oxygen. Okay, so even though the H2 in theory could make 10 moles, it really can't, because we're going to run out of oxygen too quickly. Okay, if you've kind of forgotten how that works, if we just do a very quick cheese sandwich business here, remember our cheese sandwich. If you have 4 slices of bread and you have 3 slices of cheese, how many sandwiches could you make from your 4 slices of bread? Just type it in. Yep, 2 sandwiches. That's how much we could make from our bread. All right, how much could we make from our 3 slices of cheese? If we had all the bread in the world, we could make 3 sandwiches. However, we don't have all the bread in the world. We only have 4 slices of bread. And so our limiting reactant then is the bread, because it limits how many sandwiches we can make. And we are going to have 1 slice of cheese will be left over at the end. Okay, so just like in the cheese example, we go back and we say, okay, we made 6.25 moles, so my limiting reactant is, who is the limiting reactant from our question? Is it H2? Is it O2? Or is it H2O? Go back up so I can see. Good plan. There you go. Yeah, good stuff. Okay, so our O2 is the limiting reactant. So any limiting reactant problem is going to start that way. All right, first thing you have to do if you're given 2 different reactants is you're always going to have to find who is limiting. When you found who is limiting, you also know who is excess. Anything else you do after that, you're going to always be starting from your limiting reactant. Okay. So in this particular question, we are asked which reactant is present in excess. So which reactant is present in excess? Yeah, it has to be our other one. Yeah, it has to be the H2. Okay, and we also want to know by how many grams. Well, in order to do that, you are finding the leftover mass of the H2. Just like in our bread and cheese problem, to find out how much was left over, if I was like, oh, how much is left over, I would say, well, if I use my limiting reactant, I have one sandwich, two sandwiches. That's going to use two slices of cheese. So what I do is I take my three slices that I started with and I subtract the two slices that I used to make the two sandwiches. So we always take what we start with and then we subtract what we use to react with the limiting reactant. Okay, so it's going to be the mass of H2 at the start minus the mass of H2 used with the limiting reactant. And in this case, the limiting reactant is O2. So you're going to calculate the mass of H2 used starting from the O2. Okay. So mass of H2 used up reacting with the limiting reactant, the O2. Woo, that was ugly. Okay. So O2 is where we're going to start. We had, where'd we go? 100 grams of O2. Okay, so that's what we're starting with. 100 grams of O2. And then that's going to be, we want to find the mass of H2 used up. So what do we have to convert grams of O2 into to finally get to mass of H2? Grams of O2 have to go to first thing you always convert to moles. Yeah. Okay, so we're going to convert to moles of O2. And that means, yeah, we need to use 32 grams per mole. Okay. Our second step, if we've started anywhere other than with moles, our second step is always going to be converting from moles of one substance to moles of the other substance. So we're going to convert from moles of O2 into moles of, what are we looking for? H2. And we get that mole ratio, pardon me, from the balanced reaction. The O2 has a 1 and the H2 has a 2. O2 has a 1 and the H2 has a 2. Okay. And finally, we are trying to find the mass of H2. So we need to cancel moles of H2 and find grams of H2. And because it's 2, each one weighs 1. There we go. So now we have 100 times 2 is 200 times 2 is 400 divided by 32. And we get 12.5 grams of H2 was used up reacting with the O2. So it's like that cheese. How much cheese did we use to react with all the bread? We used 2 slices of our 3 slices of cheese. So we're going to take our leftover mass and find that leftover mass of H2 is equal to the mass at the start. How much was that? It was 20 grams of H2 at the start. 20 grams. That was at the start. How much did we use? We just calculated that. We used 12.5 grams to react with all our oxygen. 12.5 grams. That's how much was used. And we get, so we have 20 minus 12.5 equals 7.5 grams. And because we have done a subtraction, remember the addition and subtraction rule for sig figs? We go to the first uncertain digit. Okay, that's different than multiplication, where we go to the least sig figs. We go to our first uncertain digit. Our uncertain digit in the 20 is the 0.0. The uncertain digit in the 12.5 is the 5. And that means that our tenths position is our first uncertain digit. And so that means that is our uncertain digit. So we are left with only 2 sig figs. Okie dokie.